Electric vehicles need copper wiring, and wind turbines need magnets that are made from rare earth elements. Solar panels use dozens of specialized metals, and yet the places where we dig for these are getting harder and harder to find. But geologists have just published a fascinating study. They found at the edges of Earth's continents, there are a higher likelihood that some of these minerals are kind of hiding out and lurking there. These are zones where copper, cobalt, and other rare earth elements are collecting in a sense and have been for millions of years. This insight could help reshape how we look for all those minerals and metals that we need in our energy expansion or energy addition. So let me walk you through what all of this means and how we could take advantage of it. Okay, so the problem is that lithium, cobalt, copper, and quite a few other rare earth elements, we're going to need them, and so the need for them is projected to soar. Meanwhile, the grade of many existing ore deposits is declining and new discoveries are harder to come by. So a team led by Dr. Chen at Macquarie University recently published a Nature paper showing how certain regions near craton margins, so those are those outer edges of Earth's ancient continental cores that I mentioned, may act as natural concentration zones for metals. Their experiments and global data suggest that there are melts rising beneath the craton that then migrate outward, lose their silica, and deposit metals in belts around the margin. And so these are not random deposits, but they're representing long-term geologic processing. In a sense, they're kind of like these metal pathways that have been developing over hundreds of millions of years, and they're just hidden beneath our feet. So now picture a craton, okay? So that is like the thick ancient core of the continental crust that's been around for, probably at least 500 million up to billions of years. Deep below it, melts from the mantle start flowing upwards, and then as they hit the bottom of that craton, they move outwards towards the edges of the craton. So kind of in a sense, moving from the craton center out towards its edges. As these melts travel, they go through chemical changes. They lose silica and become more carbonate rich. And what happens is then the silica drops and the melt can't hold on to the sulfur and metals anymore. So sulfide minerals start precipitating out. And this process creates accumulations of copper, sulfur, and other critical metals in those mantle zones beneath those craton margins. So later, when volcanic or magmatic activity taps into these zones, those metal-enriched rocks can get pushed towards the surface of the Earth and worked into some of the ore systems that we're looking for. The researchers even found that in volcanic zones at the edges of the cratons, they had some elevated copper and sulfur, and that ends up validating some of what their model predicts. So these aren't really literal roads or superhighways of metals, but they're just linear-ish regions, kind of chemical pathways that have been carved out over geologic time. So this metal pathway model suggests that we should be focusing on the craton margins for finding some new deposits of these minerals. These would be in areas in Canada, Australia, Brazil, Africa, and elsewhere. These areas might harbor enriched belts that conventional exploration has overlooked. And so by focusing drilling campaigns where geology already signals there could be melt enrichment, we may reduce some of our wasted effort and environmental impact from a broader, blinder exploration methods. And so this work comes at a critical time because the IEA has recently suggested that under current plans, future demand may outpace the new supply that we need for copper and other metals. So we need new sources and we need them fast. So this new model is kind of super exciting, but it's not going to change things overnight. Even when we know where the metals are, it still takes 10 to 20 years, massive investments, permits, infrastructure, and all of that fun stuff to get set in place. What I love about this research is how it ties our technology future with Earth's geologic history and past. These cratons formed billions of years ago, just because of the way the Earth cooled through time and the way the Earth's interior behaves. And so the energy transition doesn't just depend on new battery designs or new solar farms, but it also depends on reading our planet's history and understanding where some of those minerals we need may be already concentrated. So next time somebody talks to you about mineral supply and demand, perhaps that we don't have enough of these metals, think about how underneath the Earth, beneath your feet, particularly perhaps at the edges of cratons, there lie these superhighways of metals just waiting for us to find them. As always, thanks for listening and have a wonderful day.